Chemistry video lessons. Naming acids. Now here's a list of some common acids. Many of these we've used in lab. We've got hydrochloric acid at the top, sulfuric acid here. We've got nitric acid, very strong acid, and those are the main ones, and then acetic acid, okay, phosphoric acid, okay. Citric acid, although we use that a lot, it's not something you're going to be tested on, along with lactic acid, boric acid. So these that are sitting in here is not something I'd have to worry about too much as far as a test. And of course our perchloric acid, you won't have to use much on a test. But naming an acid is very, very simple, and I'll show you what the rules are. Okay, to begin with, an acid, the definition of it is something that is going to donate a hydrogen ion, okay, to its surroundings. So an acid can be made from any one of my polyatomic ions or my group 17, which we call the halogens, okay. And all we're going to do is we're going to look at those elements or those polyatomic ions, and we're going to determine, very importantly, what is the charge on the anion. Once we have that determined, then it's very simple. All we have to do is add hydrogens to balance it out. Okay? Now, these here are what we call the halogen family. Okay? And these are very important. These are the ones that we use a lot of, and there's a naming rule from that. Okay? So, halogens usually are always going to have a -1 charge. So when we balance those out with our hydrogen up here, which has a +1 charge, it becomes very, very simple. One hydrogen to one of these halogens, either fluorine, chlorine, bromine, iodine, are the big ones up in here, and then you can balance out your acid, and then we'll learn how to. Polyatomic ions, you know the 8 that you have to pay attention to that we have given you, okay? So the polyatomic ions that you're going to have to know is ammonium, but as you can see, it has already got a positive charge on it. So it already is basically an acid because it can donate one of the hydrogens and become ammonia. The ones you're going to have to make sure that you know is nitrate, sulfate, hydroxide, phosphate, carbonate, and acetate. Those are the ones that you have to have memorized. The rest of these here, if we ask you any questions on that, you will be given those. Now, here is the basic rules, okay? When I determine what the charge is and I get it balanced out, then the prefix, whenever I have just one of my main elements, okay, not a polyatomic, very important, not a polyatomic, just an element. So like chlorine or bromine or iodine from my halogens there, okay? What I'm going to do is, you just heard me call this chlorine, okay? So this is called chlorine, and we know it has a -1 charge. Now to name this, what we will do is we're going to take and get rid of this INE at the end, and we're going to add IC. And at the start of this, we're going to say, we're going to list our hydrogen. So we're going to call it hydro. Okay? So this is called hydrochloric acid. If I'm using the bromine here, which has a -1 charge, then we're going to take our hydrogen and put hydro, bro. We drop the INE, add the IC, hydrobromic acid. Okay, so anytime that we have just one of our halogens, we add the hydro, put the main part of the name in, drop the INE, add an IC, and then call it its name. Now, if we have a polyatomic ion, and we always can tell polyatomics because we know they have lots of oxygens, the name of the polyatomic ion becomes the main part of the name. Okay? If the ending of the polyatomic ion ends in ATE, drop it and add IC as we were talking about. If the ending of the name of the polyatomic ends in ITE, drop it and add OUS, okay? Now, you do not have to memorize any of the ones that have an ITE on it, like nitrite, okay? You do have to memorize nitrate. So your biggest deal is going to make sure that you have take the ATE off, get rid of it off the end of the word, and you're going to add, okay, you're going to add an IC. So, let's see if we can do some practicing here. Let's take nitric, okay, I'm going to take the nitric acid right here, okay, and we're going to take nitrate. So we take nit, we drop the ATE and add an IC, and then add acid to it. Let's take and we add C2H3O2 with a -1 charge. This is acetate. Okay, that's the polyatomic ion you have to memorize there. So how would we do this? We would take and we would drop the ATE off the end, and then we would add IC. So this would be acetic acid. Okay, and its formula would just be, we'd get rid of this here and we add the hydrogen and put it in front, and that's very important. Always add the hydrogens in front. This would be HNO3 for our nitric acid, okay? So naming acids is very simple. If I have any one of my elements from group 17, okay, I put a hydro in front, I name the element, and I drop the INE or the IDE and add an IC, okay? Hydrochloric acid, all right? If it's a polyatomic, I don't put the hydro in front. I just use the name of the polyatomic ion. I put the IC at the end of it, drop the ATE, and make it an acid. If I got to make the compound formula, all I have to do is put in hydrogens to balance out the charge of whatever the polyatomic ion. So one last example right here. If I have phosphate, PO4 with a 3- charge, I need 3 hydrogens. So its formula is going to be H3PO4. And its name, which I'll write up along the side over here, would be phosphoric acid. Okay? Now I would go over this as many times as you need to make sure that you can create an acid from any of the polyatomic ions that we've been given that you need to memorize, and anything from group 17. Remember, chem is try, never give up, and stay gritty out there.